So I'm going to work through some examples of simplifying logarithms. So first, as long as we know the vocabulary, so the way I would read that first expression is log base b of x. So this, the little number, and it's a subscript, it's called the base. It'll be a number, and not only will it be a number, but the base has to be greater than 0 and not 1. And the x I call the argument. It's what we're taking the logarithm of. So a log doesn't make sense unless it has an argument. Make sure I can spell there. And what we're looking for as an answer is, so remember back from exponents, the base, right? Base raised to what power gets me the argument. So I'm trying to come up with the exponent that I would need to go from the base to the argument. Okay? And I have this whole counterclockwise circle that I do in my brain, and I'll show you as soon as we get an answer. Okay, so log, be sure to read it out loud so you can hear it too, log base 2 of 16. So we have to get from 2 to 16 with an exponent. So 2, here's my circle, raised to what power gets me 16, right? And 2 to the 4th is 16. So since 2 to the 4th is 16, log base 2 of 16 is 4. Okay. Log base 6 of 216 is, okay, so either you have this going, a little counterclockwise circle, 6 to the what? Or off to the side you say, 6 raised to what power gets me 216? Okay. Your answer to simplifying this is that exponent. 6 raised to what power to get 216? 3. Okay. Now this next one is kind of tricky in that it's so simple. Log base 10, you're right, that is a common log. We call it when it's base 10. And like in square roots, that's the only time you don't have to write the little 2. For logs, if it's a 10, that's the only time you don't have to write it, but I'm being explicit here. So log base 10 of 10 to the 12th. The base raised to what power would get me 10 to the 12th? So 10 to the what equals 10 to the 12th? Exactly, just 12. Okay, now I'm going to raise the bar. Log base 5 of 1/5. See, and even when you say it base 5, it tells you that when you go to write it the other way, 5 is the base, and we have to find an exponent. And somehow we have to use that exponent to transform my 5 into a 1/5. Well, how do I do that? How do I turn a 5 into a fraction? How do I send it down below a fraction bar? Exactly, with a negative exponent. So 5 to the negative 1 is the same thing as 1/5. So that's your answer to the simplifying. Okay. Notice my base, right? It's always positive. My bases have all been positive, and they've been greater than 0, so positive, and none of them is 1. Okay, 4 more examples. Trying to get a little trickier. Hit all of our exponent properties. So log base 9 of 3. 9 raised to what power is 3? So you, right, it's not a dividing by, it's a what do I do to it? Right? What do I do to it with an exponent to get me to the 3? Well, I could square root it. Right, the square root of 9 is 3. That's a true statement. Can I write a square root of 9 as an exponent, as a 9 to some power? Right, 9 to the 1/2 is 3, because square rooting is same as raising to 1/2 power. So log base 9 of 3 is 1/2. Oh my gosh, I'm getting super tricky now. But I did it following this one, right? So I'm trying to lead you there. Log base 9 of 27. So now I have to get from 9 to 27 just with an exponent. So 9 with the exponent to get to 27. So we just did the square root of 9 got me to 3. And if I could, do you see it? Right? If we could cube the 3 would get to the 27. So if I cube the 9 to the 1/2, what would that look like? So here's what it looks like as a radical, right? I need to square root 9 to get down to 3. And then I need to cube it, and that will get me to the 27. Okay? So if you're worried that I'm using radicals instead of exponents, remember how they're related. If you have a radical, you can write that as a fractional exponent, right? So 9, the radicand is your base, and then the index, that 2 that we don't write, is the denominator, and 3, the thing we raise it to, is the numerator of the exponent. Okay. So since this is true, 9 to the 3/2 is 27. Log base 9 of 27 is 3/2, right? Or 1.5 or 1.5 or however you do that. Okay, 2 more, and I've brought in a new base for you. So when you use the letters ln, this stands for natural log. So ln refers to a natural logarithm, which means a log base e, okay, where e is that number between 2 and 3. Okay, so you could write log base e of x, and that means the same thing as the natural log of x. Okay. You'll notice your calculator has this button on it somewhere. Okay. So if I have the natural log of e to the 3rd, it might help you, just like that base 10 power we had before, if instead of writing the ln, we write log base e. My argument is e cubed. So the base raised to what power gets me e cubed? Exactly, 3. E to the 3rd equals e to the 3rd. Okay. Oh, that looks hard to read on this last one. I have the natural log of a 5th root, that's a little 5, 5th root of e. So you have to remember some exponent properties. It's one we've practiced a couple of times already, though. So maybe you're going to do this, log base e, because it just feels better. And then e, if it has a 1/5, well, if it has an index of 5, that's the same thing as raising it to a 1/5 power. So log base e of e to the 1/5 is exactly just that exponent, 1/5.